Alright, exercise 10.2 says refer to exercise 10.1 and it says suppose the sample had the same composition but was 10 times as large. 1550 white, 400 yellow, and 100 green, which means we would have 2050 squash. Okay, so our proportions will stay the same, except the number expected, because these numbers are simply 12/16 times 2050, and we made this number 10 times bigger. Our expected numbers just become 10 times bigger. So these become 1537.5, and here we have 384.375, 128.125. And one of the neat things is because of these properties, everything is being multiplied by 10, and we can we're moving these things around. Okay, all of these decimals and everything is getting bigger by 10. In fact, the only thing that changes is that our chi-squared statistic itself becomes 10 times bigger. Alright, so here this quantity becomes 0.101, this becomes 0.635, and here we have 6.17, and our chi-squared statistic is 6.916 rather than 0.6916. Okay, so we still have 2 degrees of freedom. Our new chi-squared statistic is 6.9106. Okay, and you can redo the math yourself and see for yourself, but you will get the same number. The expected, the observed got 10 times bigger, and the expected numbers got 10 times bigger. And so when we look up 6.916 under 2 degrees of freedom, we see that to find our tail probability, okay, 6.916 is between the numbers 5.99 and 7.82, which correspond to a tail probability of 2% and 5%. So that means our p-value is going to be between 2% and 5%. And if alpha is equal to 10%, then that means our p-value is smaller than alpha, and we would reject the null hypothesis. Okay, and in this case, our alternative, as before, was the null was data model fits the data. The alternative is that the model does not fit the data. And so if we observed 10 times as many squash and the proportions were exactly the same, we would reject the null hypothesis and say these numbers are not a good model for the data.